7031. The primary purpose of practicing operations at reduced airspeeds is to enable students to a. Safely fly airport traffic patterns at various airspeeds. b. Develop proficiency in anticipating the onset of power-on stalls. c. Develop proficiency in their sense of feel and their ability to use the controls properly at various speeds. The correct answer is C. When flying an aircraft, it is essential for pilots to have a good sense of feel, which refers to their ability to sense and interpret the aircraft's behavior through their control inputs. Different airspeeds result in varying flight characteristics and control responses, and practicing operations at reduced airspeeds allows students to develop a better understanding of how the aircraft behaves and responds in these situations. By flying at reduced airspeeds, students can experience firsthand the changes in control effectiveness, control sensitivity, and aircraft stability. They learn to adapt their control inputs to these changes and develop a more nuanced understanding of the aircraft's handling characteristics at different speeds. This proficiency in sense of feel enables pilots to make precise and coordinated control inputs, enhancing their overall control of the aircraft. Furthermore, practicing operations at reduced airspeeds also helps students develop their ability to use the controls properly at various speeds. They learn to adjust the aircraft's attitude, power settings, and control inputs to maintain control and prevent stalls or other adverse situations. This practice enhances their coordination and mastery of the flight controls, enabling them to fly safely and effectively at different airspeeds. Overall, by focusing on developing proficiency in their sense of feel and ability to use the controls properly at various speeds, practicing operations at reduced airspeeds prepares students to handle different flight conditions and enhances their overall flying skills. 7035. If inadequate right rudder is used during a climbing right turn, what may occur if the aircraft stalls? A. A spin to the left. B. A tendency to yaw to the right. C. A tendency to roll to the right. The correct answer is A. During a climbing right turn, the aircraft is in a banked attitude and is turning to the right. In order to maintain coordinated flight, the pilot needs to apply the appropriate amount of rudder input to counteract the adverse yaw that is generated by the ailerons. Adverse yaw is a phenomenon where the aircraft yaws in the opposite direction of the intended turn when ailerons are applied. In this case, inadequate right rudder means that the pilot is not applying enough rudder input to overcome the adverse yaw generated by the right aileron being raised. When the aircraft stalls, the airflow over the wings becomes disrupted, and the wings may lose lift. If there is insufficient right rudder to counteract the adverse yaw and maintain coordination, the aircraft will have a greater tendency to yaw to the right due to the increased drag on the left wing. As a result, the left wing, which is experiencing less drag, will generate more lift compared to the right wing. This imbalance in lift can lead to an uncontrolled roll to the left, which, if not corrected promptly, can develop into a spin to the left. Spinning is a dangerous and potentially deadly flight condition where the aircraft rotates rapidly about its vertical axis while descending in a corkscrew-like motion. In this scenario, the inadequate right rudder exacerbates the yawing tendency to the right during the stall, ultimately leading to a left spin. 7033. If an accelerated stall occurs during a steep turn, in which direction would the aircraft tend to roll? A. Toward the inside of the turn. B. Toward the outside of the turn. C. The direction of roll depends on whether the airplane is slipping, skidding, or in coordinated flight. The correct answer is C. When an accelerated stall occurs during a steep turn, the direction of roll depends on whether the airplane is slipping, skidding, or in coordinated flight. Here's the reasoning behind this answer. During a steep turn, an aircraft is operating at a high angle of bank, which increases the load on the wings. If the pilot continues to increase the angle of bank or pulls back on the elevator excessively, the aircraft may exceed its critical angle of attack and enter into an accelerated stall. In an accelerated stall, the stall occurs at a higher airspeed compared to a normal stall due to the increased load on the wings. The airflow over the wings becomes disrupted, and the aircraft may experience a loss of lift and control effectiveness. 7032. If an accelerated stall occurs in a steep turn, how will the aircraft respond? A. The inside wing stalls first because it is flying at a higher angle of attack. B. The outside wing stalls first because it is flying at a higher angle of attack. C. In a slip, the high wing stalls first. In a skid, the low wing stalls first. In coordinated flight, both wings stall at the same time. The correct answer is C. When an accelerated stall occurs in a steep turn, the response of the aircraft depends on whether it is in a slip, skid, or coordinated flight. Here's the reasoning behind this answer. Slip. In a slip, the aircraft is in a banked attitude, but the nose is pointing inside the turn, and the flight path is slightly to the outside of the turn. In this situation, the high wing is flying at a higher angle of attack compared to the low wing. When an accelerated stall occurs during a slip, the high wing, which is exposed to a higher angle of attack, stalls first. This is because the higher angle of attack on the high wing results in a higher critical angle of attack, and it reaches the critical angle of attack before the low wing. Skid. In a skid, the aircraft's nose is pointing outside the turn, and the flight path is slightly to the inside of the turn. In this condition, the low wing is flying at a higher angle of attack compared to the high wing. When an accelerated stall occurs during a skid, the low wing, which is exposed to a higher angle of attack, stalls first. This is because the higher angle of attack on the low wing results in a higher critical angle of attack, and it reaches the critical angle of attack before the high wing. Coordinated flight. In coordinated flight, the aircraft is in a properly balanced turn where the nose is aligned with the direction of the turn and the flight path is centered within the turn. In this case, both wings are flying at similar angles of attack. When an accelerated stall occurs during coordinated flight, both wings stall at approximately the same time. This is because the angles of attack on both wings are similar, and they reach their respective critical angles of attack simultaneously. 7034. Students should be taught that throughout a level, 720-degree steep turn to the right, the rudder is normally used to A. Prevent yawing. B. Control the rate of turn. C. Hold the aircraft in the turn once it is established. The correct answer is A. In a steep turn, the aircraft is banked at a high angle to sustain the desired rate of turn. When the aircraft is in a banked attitude, the ailerons primarily control the roll by raising or lowering the wings, while the elevator controls the pitch to maintain altitude. The rudder, on the other hand, is primarily used to control yaw, which is the side-to-side movement of the aircraft's nose. Yawing occurs due to the adverse yaw effect, which is the result of unequal lift on the wings during a banked turn. The downward aileron creates more drag on that side, causing the nose to yaw in the opposite direction of the turn. To counteract this adverse yaw and maintain coordinated flight during a steep turn, the pilot needs to apply the appropriate rudder input. By applying right rudder in a steep right turn, the pilot counteracts the yawing tendency and prevents the nose from yawing to the left. This helps maintain coordination and keeps the aircraft's flight path aligned with the turn.